Welcome to True Projects. In this video, we are going to explain about the project that is e-commerce fraud detection based on machine learning techniques, systematic literature review. So before getting into the execution, first let us understand what is the project about. Did you know that during COVID-19 pandemic, the way we lived and worked underwent a massive shift? Suddenly, everything moved online, from shopping, schooling, it even moved to doctor appointments. So platforms like Amazon, eBay, and work that is Facebook Marketplace became lifesavers, making it easy for people to get what they need without stepping outside. Sounds amazing, right? But here the problem is these platforms made our lives more convenient as they also became hot targets for the fraudsters. So some of you might have faced it that you have found a great deal, you made a payment and waited eagerly for your order. Days have passed and nothing has been arrived. Worse, your money has gone and you can't even track the seller. So, this is just one example of the many cyber crimes that have skyrocketed, such as phishing, emails, tricking people into giving away sensitive information, or malware silently stealing the credit card details. These crimes don't just drain the money, they can also ruin reputations and cause a lot of stress for individuals and businesses. With e-commerce now such a big part of our daily lives. E-commerce is such a big part of daily lives, ensuring security has also become more critical than ever. Fraud is constantly evolving, and staying one step ahead requires smart systems and strategies to protect both businesses and also the customers. Moving on, fraudsters are getting smarter every day and they're not playing by the same old rules. So they're not using the same old rules, they are getting updated day by day. They're always finding new tricks, and traditional fraud prevention methods just can't keep up. Think of it like a cat and a mouse game where the mouse keeps evolving faster than the cat can react. Here, the tricky part is e commerce platforms are incredibly complex. So they are incredibly complex. They are built with layers upon layers of system. They're not just simple websites, they are built with layers upon layers of systems. They uses interfaces, business logic, databases, and even connections to external services like payment gateways and logistics. So each of these layers can have weak spots that attackers can exploit. It's like trying to defend a fortress with dozens of hidden doors you didn't even know existed. So what's the solution? We need fraud detection system that can go beyond basic checks. These systems should be able to analyze massive amount of data, spot patterns, and even identify unusual activities in real time. It's the only way to stay ahead of the game and ensure the people continue to trust these platforms for secure and seamless online transactions. After all, no one wants to worry about losing their hard earned money while shopping for something as simple as groceries or a birthday gift. As fraud on e commerce platforms is a big challenge, and addressing it isn't as straightforward as it seems. So, in this project, we are going to conduct, we have conducted a comparative study by analyzing, by training different machine learning models to see which one works best for spotting the fraudulent activities. And one major issue with the fraud detection is the class imbalance in the data set. Let me explain you what is this class imbalance. So in the data, we will be having fraudulent transactions fewer, we will be having less fraudulent transactions than the genuine transactions. And this makes it harder for the models to learn and predict them accurately. So to solve this issue, we are using something method called some different technique called SMORE technique, that is nothing but synthetic minority oversampling technique, which helps to balance the data set by creating synthetic samples of the minority class, that is the fraud class here, without just duplicating the existing ones. So this gives the model a fair chance to learn patterns from both the fraud and legitimate data, that is the genuine data. And then we train different machine learning models that are logistic regression, random forest, decision tree, naive Bayes, support vector machine, artificial neural network, k-nearest neighbor, XGBoost, cat boost, ada boost, and gradient boosting. So we will be training all these models and evaluating them using accuracy, precision, recall, and FN score, and find out the best performing model and deploy the project. So the idea is to find out which model or which models handle the complexity of e-commerce data the best. Each algorithm has its strengths, and by comparing them, we get a clear picture of their performance, limitations, and suitability for the real world fraud detection. This isn't just about building the models, it is about gaining deeper insights into to make online platforms safer and more reliable for everyone. Moving on, to further improve the performance, we have incorporated voting classifier algorithm, which is an ensemble method. This combines the predictions of multiple individual models to create a single and stronger prediction. This way, it balances out the weakness of one model with the strengths of the other, resulting in more reliable and accurate fraud detection. Moving on, as a front end of the project, we have developed that front end using Flask framework. This is the extension. This makes it easy for users to interact with the system and test it in a practical way. To ensure the security, we have added user authentication mechanism. This only allows authorized users can access the tool. This makes it the system not just accurate but also user friendly. Moving on to the implementation of the project. To implement, we have followed the steps in the flow of work. So first, what we have done is we have imported the packages. We start by importing all the required Python libraries and modules needed for data analysis, pre-processing, visualization, building machine learning models. Then the next step is exploring the data set. So next we take a closer look at the e-commerce data to understand its structure, the number of records, types of features, and any missing or unusual values. So this gives us a good starting point for the analysis. Coming to the next step is data processing. So here what we do is we remove duplicate entries to avoid redundancy. Here we clean up the data set. So here we remove the duplicate entries to avoid redundancy and also ensure accuracy. Additionally, we also, the irrelevant unnecessary columns are dropped during this step. In the next step, we create visualizations. So here we create graphs and plots to visualize the patterns in the data like transaction trends, distribution of values, and class imbalances, which can provide insights for model building. Then we convert all the numerical categorical variables into numerical values. So here categorical variables will be converted into numerical values using label encoding to make the data compatible with the machine learning models. After that, we identify the most relevant features that significantly impact the outcome, ensuring the models focus on meaningful data while reducing computational overhead. Since the fraudulent transactions are usually fewer compared to the genuine ones, we use SMORE technique to balance the dataset by generating synthetic samples for the minority class, making it easier for models to detect fraud. The next step we have is splitting the dataset. So the data is divided into training and validation sets to ensure the models are trained on the part of the data and tested on other for unbiased evaluation. The next step involves creating the framework for various machine learning algorithms. Here we test logistic regression, decision tree, and XGBoost. Here we initiate all the machine learning models and then they are trained on the training data set. So they can learn to identify patterns and make predictions. And we compare them, we evaluate them using accuracy, precision, recall, and FN score, and we compare them using graphs. A user-friendly web interface is created using Flask. It includes registration and login functionalities with SQLite as database for securely storing user credentials. And then users, they will be able to provide the input in the front end for new transaction, for prediction of the fraud. And then that input will be pre-processed at the back end. It will be fed with the trained model and in the front end, finally, we will be getting the prediction whether it is a fraud transaction or it is a normal one. Moving on to the algorithms used, here we have implemented all these algorithms. Here we have implemented logistic regression, decision tree, random forest, naive Bayes, support vector machine, ANN, KNN, boosting models that are CAD boost, ADA boost, gradient boosting, and XGBoost. These are all the algorithms which are used for classifying the fraud in e-commerce transactions. So this is the extension model voting classifier which has achieved the highest accuracy. Moving on to the requirements part, to implement this project, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. This is all about the theoretical concept. Now let's execute. To execute, open the code folder, which contain source code files. So let us open the code folder of the project. These are the source code files in the code folder of the project. Let us understand how will they be used in the project. So here in this data folder, we have the data set that is used in the project. So here we have fraudulent e-commerce transaction data that is used to train all the models so that they will be able to detect the fraud. Let's get back. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have the model file. This file contains the algorithm information that will be loaded into the project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have the signup.db file. This file is a database file which is used to store the user information. Coming to this process file, initially we had main data in this file, right? So this is the raw data. After doing necessary pre-processing steps, it is saved as processed dataset file. So this is the processed dataset. After doing pre-processing, this is the dataset. So these are all the individual columns that impact in the fraud. So here this is the target column, and these are all the independent variables. So these are all the independent variables that impact the fraud. So based on these only, we will be categorizing the fraud. Let's close this. And here in the sample file, we have the test cases that we will be using in the front end to detect the fraud. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So copy the path. Now open the Anaconda prompt. Give the command cd followed by the space and paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folders path. Now we have to compile the app.py file. So give the command python space app.py and now click on enter. So this will compile app.py file and will execute Python script and perform runtime check for syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the local host and port. It will host at the default address, that is the local host and the port, unless configured differently. So we have to copy this local link provided by the Flask framework where the application has been hosted. Copy that and you can paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. And this is the web page of the project, which is displayed in the browser. So here you can see sign up link, right? We need to click on that and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in, give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see various inputs, right? So here you can see various parameters that are need to be entered. Based on the given parameters, we will be getting the prediction. So first, let us understand what are these. First, we have is the transaction amount. This is the total value of the transaction made by the customer. It helps to determine whether the transaction size is typical for the customer or unusually high, which could indicate the fraudulent activity. The next one we have is the payment method. This refers to the payment method used for the transaction such as credit card, PayPal, or any debit card. Different payment methods might have varying levels of the fraud risk. Coming to product category, this represents the type or category of the product being purchased, like electronics, clothing, or groceries. Some product categories might be more commonly targeted by the fraudsters. The next one we have is the quantity. This is the number of the items being purchased in a single transaction. A very high quantity might signal suspicious behavior, especially if it is inconsistent with the customer's usual buying habits. Coming to customer age, this is the age of the customers making this transaction. Age can be important factor in predicting fraud, as certain age groups may be targeted more often. Coming to device used, this refers to the device like smartphone, tablet, or desktop that the customer is using to complete the transaction. Fraudsters may use different devices to conduct fraudulent transactions, so it is useful to track this. Coming to account age days, this is the number of days since the customer created their account. New accounts can sometimes be associated with the high fraud risk, as they may not yet have a history of legitimate transactions. Coming to transaction hour, this is the time of the day when the transaction was made. Unusual transaction times take a night or during non-peak hours may raise suspicion, as fraudsters may target times when fewer staff are monitoring the transaction. So this is about the parameters. Let's enter them. For that, we need to open the sample file. Get back to the code folder, open the sample file. So these are the test cases that we will be using for predicting the fraud. Let us enter them. So let's try by using the first test case. So let's try using the first test case. Here we are supposed to enter the first transaction amount. So copy the transaction amount, that is the 198.24. Paste it. Payment method is the bank transfer. So copy that. Here we can choose it is bank transfer, and here we have product category as electronics. So choose product category as electronics. And here quantity is 2 and customer age is 52. And here device used to make the transaction is mobile. Here account age days is 16 days of account age. And here we have transaction hour, that is 3 hours for the transaction. Now click on predict. The given input, it will be pre-processed at the backend, and then trained model will be giving us the prediction whether it is fraud or non-fraudulent. So here, if you observe fraudulent, it is detected. It's a fraudulent payment. So there is a fraudulent payment detected in the e-commerce side. So this is the fraudulent. Here one refers to the, here in the target we have one, right? One refers to the fraudulent payment method. Now let's try using the second one. Click on prediction again. So here the transaction amount we have is 104.24. And here payment method is the PayPal. And here we have product category as clothing. Quantity is 1. Customer age is 37. Device used is desktop. Account age is 15 days. And the transaction hour is 12 hours. So here we have target as 1. So that means that the application should predict this transaction as also as fraud. Let's see whether it will correctly predict it or not. Click on predict. So here, based on the given input, we got the prediction. It has predicted correctly that it is a fraud in payment. So here, the payment is made and it is a fraud payment made by the customer. Let's try with this case where the class is 0. Let's try with the fifth test case. Click on prediction. So here, transaction amount is 280.89. Payment method is PayPal. Product category is electronics. Quantity is 1. Customer age is 30. Device choose this mobile to make the payment. And account age days is 100. Transaction hour is 19 hours. Now click on predict. Here it has to be predicted as no fraud. Now let's check whether it will correctly predict it or not. So here non-fraudulent. That means there is no fraud in the payment made on the e-commerce side. So the person has made the payment in the e-commerce and that is not fraud. It is a genuine payment that he has made. Now let's check with this one. Click on prediction. So here transaction amount to be paid is 79 point. Let's copy this and paste it there. And here payment made through debit card. Product category is home and garden. Quantity is 1. Customer age is 33. Device used is a desktop. Account age is 238. And here it is 15 hours of transaction. Now click on predict. So here we have prediction that fraudulent transaction has been take place. That is fraudulent payment has been done on the e-commerce site. So it's a fraud payment. Now let's try with the other case where credit card has been used to pay. Here transaction amount is 120.95. Payment method choose this credit card. Product is clothing. Quantity is 3. Customer age is 33. And here account days are 182. Here we have 17 as the transaction hour. Now click on predict. We have not filled this column, so device used this. So he has used the device tablet. Click on predict. And here we got the prediction that non-fraudulent transaction has been took place. So here there is no fraud in the payment made on the e-commerce site. So here it is not a fraudulent payment made. Now let's check with the graphs. Click on graph. So here we have the graph. So this is the sample outcome graph. Here on x-axis, we have the attack types. So here we have outcome types. Here on y-axis, we have count. 0 is the non-fraud transaction, that is non-fraud payment, and 1 is the fraud payment. Here, if you observe, fraud payments are very less than the non-fraud payments, which are nothing but the legitimate payments. So that is why we have used SMORE technique to address this class imbalance. You can understand through this graph, right? Which is class imbalance. So here it means class imbalance mean that here we have non-fraud transactions more than the fraud transactions. So if we train the model in this way, so here first graph which we have is the sample outcome graph. Here on x-axis we have the classes, that is the fraud and non-fraud. Here on y-axis we have the count of each class. 0 represents non-fraud, that is legitimate transaction, legitimate payment made, and 1 refers to the non-legitimate, that is the fraud payment made. Here if you observe, fraud payments are less in count than the non-fraud payments. So that is why we have used the SMORE technique so that we can increase the cases of 1, that is fraud payments, and then train the models. And here we have correlation matrix. This shows the correlation between variables. And here we have accuracy comparison graph. Here on x-axis, we have accuracy score of each algorithm, and on y-axis, we have the algorithm names. So these are the algorithms trained to classify the fraud payments. And here we have the precision comparison graph. Here we have recall score, and here we have FN score. So now click on sign out. In this way, just by giving the parameters that are required parameters to the application, it will detect whether it is a fraud payment type or it is genuine payment type. This will help customers to get safeguarded. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.